All right, 5-7. Yesterday we left off here, and we left off with find the zeros of each function. So we've dealt with this before. We've found the zeros before, and what we had to do in situations like this is we had to factor them, and then after we factored them, we had to set x equal to 0, and then we would figure out what each x was. So that's what we're going to go through and we're going to do today. But something interesting happens here. So let's take a look. Let's say that I decided to factor this. Talk to me about that. Let's say I factor that. I'm looking for two things that multiply to give me 5 that when added will give me -2. There are none. It's not going to factor, so we don't have anything that works out. So we still need something to do. We still need a way of finding the zeros, but this is not going to work. And this is where we get to something called completing the square. Now, what we're going to do is we're going to make some changes here so that we can do it. So what I'm going to do is I'm going to write down exactly what we have. I'm going to do x squared minus 2x plus 5. That's what we already have written there. And really what I want to happen is I want it to be equal to 0. So that's what we're going to go from here. So when we complete the square, this is what we're going to do. But we know that this is not going to work like this, that right now that plus 5 in there is not going to work out for us. So what I'm going to do is I'm going to move the 5 out of the way for just a moment. I'm going to just say, let's move it to the other side and see if that helps me. So all we've done now is we're here, x squared minus 2x. Notice that there used to be a plus 5 here. There's no longer a plus 5 there. And over here we've got equal to -5. Now remember, I'm allowed to add anything I want to both sides, right? That's allowed. As long as I do it to both sides, this is totally allowed. So what I'm going to do is this. And this is how I know what number to add there. This is the part that you got to pay attention to, because I am going to add a number here to fix it so that I can factor it, and I will add that same number to the other side because I have to do that. Now to fix it, here's how I decide what that number is. This number in the middle, you're going to take half of that number and then square it. So watch what I do here. I take -2, and then I'm going to take half of that number, and then I'm going to square it. Every single time, whatever that number is, I'm going to take half of it and then square it every single time. So what happens inside the parentheses there? What does that become inside the parentheses? That becomes -1. And then when I square -1, what do I get? So what I'm doing is I'm adding 1 to this side. But I'm also going to add 1 to this side, because that's totally okay to do as long as you do it to both sides. But the number that you choose, that you have to take half of the middle one and then square it. So now here's what we've got. X squared minus 2x plus 1 is equal to -4. -5 plus 1 is -4. Now, what I want us to do is, excuse me, I want us to try to factor this side now. Now that we've messed with that number, let's try to factor it now. Okay, we get x minus 1 and x minus 1, or x minus 1 squared is equal to -4. Now this is actually a little bit easier to solve. How do I get rid of that squared on the left-hand side? I'm going to take the square root. But if I take the square root of this side, I also have to take the square root of this side. And since I took the square root of both sides, what do I need to write on the right-hand side? I took the square root of both sides, plus or minus. So now this square root crosses out with that square and leaves me with x minus 1 over here. And over here, I've got plus or minus the square root of -4. Okay, let's talk about the square root of -4. This is what we did yesterday. I'm talking specifically about this. How did we deal with just that yesterday? Good. We're going to split it into -1 and a +4. plus or minus is equal to negative 1. Okay, so x minus 1 is equal to plus or minus. What does that square root of negative 1 become?
I.
That becomes I. What is the square root of 4? 2. So we get x minus 1 is equal to plus or minus 2i. But I still haven't solved for x. Guess what I'm going to do to get x by itself? I'm going to add 1. And I get x is equal to 1 plus or minus 2i. The reason that I wrote the 1 at the front is, remember yesterday when we started dealing with the real parts and the imaginary parts? The real part always comes first. The real part is this. This is the imaginary part because it has an I on it. That's what we're going to be dealing with these. We're going to do a couple of these. This is what I think what we're doing right now, the hardest part of today. So in just a minute, we'll move to the next one. I just want everyone to get a chance to copy that down. All right, so now we're going to go on to B. Is that going too fast? Is that...
No, you're good. I got it.
Okay. Well, just let me know. Call me out if I'm going too fast. All right. So I need two numbers that are going to multiply to give me 35 that when added will give me 10. There aren't. So we've got the only numbers that are going to give us 35 are like 7 and 5. When added will not give me 10. And 1 and 35 when added will not give me 10. So I get back to the same scenario. So here's how you know when to do this. When you can't factor, one of your options is completing the square. So we're always going to take the constant, the number that is like just, that has no x's on it, and we're going to move it to the other side. So we get minus 35. So we get x squared plus 10x. Here's the spot where the 35 used to be, and we subtracted 35 from the other side as well. So notice I just got rid of the 35. I moved it to the other side. It didn't just disappear. It's on the other side. Now, I need to do something to this number. What did I do with this number last time? Half of it, and then square it. What's half of 10 over 2? Or sorry, what's 10 over 2? That's 5, and then 5 squared is? So that's a positive 25 that I'm adding to the side. But I also have to do it to the other side. Which puts us here. X squared plus 10x plus 25 is equal to negative 10. Now, I'm telling you, once you do that, once you take half of the middle number and square it, you will always be able to factor it. So let's go and now and try to factor this. X plus 5 times x plus 5 is equal to negative 10, which becomes x plus 5 squared equals negative 10. By the way, it is no coincidence that the last one is squared and this one is squared as well. We call it completing the square. It'll always work out that this left side is like x plus something squared, x minus something squared. It's going to be the same number. Like we're going to keep having this twice. So how are we going to deal with that x plus 5 squared? All right, we're going to square root this side. We're going to square root this side. And we get x plus 5 is equal to plus or minus the square root of negative 10. Help me deal with that square root of negative 10. Okay, that becomes the square root of negative 1 and the square root of 10 plus or minus x plus 5. X plus 5 is equal to plus or minus I times the square root of 10. Does the square root of 10 break down? No, its only factors are 2 and 5, and I can't break either one of those down. So what else do I need to do to get x by itself? We're going to subtract 5. So we'll subtract 5 here, and we will also subtract 5 on this side. Is that a weird number? Yes, it looks really weird, for sure. So we get negative 5 plus or minus I times the square root of 10. I'm going to do only one more of these. I'm going to do C. It's going to be the same pattern every single time. So just so that we can get used to it, it's going to be those same steps every time. It's not going to factor. So I'm going to complete the square, and then I'm going to end up in this scenario every single time. But the key to remember there is move that constant, the one that doesn't have x, move it over all by itself, and then we're going to take half of the middle term, half of the middle term, and then square it. Okay. Does this factor? No, because the only things that make 13 are 13 and 1, and that's not going to end up as 4. So we get x squared plus 4x. Now, I'm going to subtract 13 from both sides, and I end up with this gap there. And I leave that gap there to remind me that the number is going to go there each time. Okay. Talk to me. What am I going to do? Okay, half of 4, and then square it. What is half of 4?
2.
And 2 squared?
4.
Is 4. So I'm adding 4 to both sides, which puts me here. X squared plus 4x plus 4 is equal to negative 9.
And then if you factor, it's x plus 2 squared.
X plus 2 times x plus 2 is equal to negative 9, which is x plus 2 squared is equal to negative 9.
Then you square root it.
Okay, we'll do the square root of both sides. And since we introduced the square root, we got to make sure to go x plus 2 is equal to plus or minus the square root of negative 9.
And then you split up the square root of negative 9 by square root of negative 1 and square root of 9. The square root of negative 1 is imaginary, and the square root of 9 is 3.
So that becomes 3. That becomes I. Moving down.
Then you go x plus 2 is equal to plus or minus 3i. And then you would subtract 2.
Good. Subtract 2. And then we get x is equal to negative 2 plus or minus 3i. Thank you. Can you put your drink up in the cabinet there so it doesn't... And that's our answer. X is equal to negative 2 plus 3i, and x is equal to negative 2 minus 3i. So it's two answers there. Plus or minus means that there's a plus 3i and a negative 3i. So let's go on to the next section, because there's actually like 3 sections we have to do. That was the hardest of them. If there's time at the end, I'll come back and we'll do D, but right now, let's just try to get through as much as possible. Okay, so we're going to talk about complex conjugates. Remember when we found conjugates, we realized that in the denominator that we took the opposite. Let's say that we had a situation like this. I had 1 plus the square root of 2 in the denominator, and I wanted to get rid of it. What we did was we multiplied by the conjugate. What would be the conjugate for that? 1 minus the square root of 2. So all we did in that situation was change that square root part, that second term, from plus to minus. If it had been a minus, we would have changed it to plus, and it fixes that situation. Now, we are going to find the conjugate for all these things, because all of these things, we are going to find the conjugate of all these. Now, what we're going to do for these is that we have to make sure that we first write them with the real number first. You always have to write them with the real number first. Is the real number written first? No. Remember, the real number is the one without the i's. That needs to be written first. So I'm going to rewrite this. Again, you will make big mistakes unless you rewrite this. So it's negative 15 plus 2i. Now, to find the conjugate, you're going to do the exact same thing you've always done. You're going to be like, seriously, that's it? Yes, this is it. To find the conjugate, all you need to do is make sure the real number is written first, and then we are going to change this from a plus to a minus, or from a minus to a plus. In which case, this is going to be negative 15 minus 2i. Notice I don't change both signs. I only change the one that's separating the two numbers there. But the real number has to be written first. So my final answer, negative 15 minus 2i, is the conjugate for 2i minus 15. But really, we have to rewrite it like this first. So this one should feel super easy because it's like, really? There's no real work involved? Not really, other than maybe you have to rearrange it first. The biggest error that people make on this one is they write this as the conjugate, 2i plus 15. They write that as the answer. That's not the answer. That's not the conjugate because you have to write the real portion first. All right. Take a moment. There is definitely an imaginary number there, yes? Mm-hmm. And what if I told you there's a real number there too?
-1.
What's that? No, whatever is attached to the I, whatever is attached to the I is part of the imaginary. So I'll tell you right now, this is the imaginary. And I'm telling you right now that there is also a real number there as well. What's that? It's actually a 0 minus 4i. There are no real numbers there, right? There's nothing that is not touching that thing. So we have to call this, to be able to find the conjugate properly, we're going to call this our real number right here. There's 0. How many real numbers are there? 0. What is the real number there? 0. But this is still exactly the same. So if you think about it, the conjugate of this would be, what would the conjugate of this be? 0 plus 4i. And what is 0 plus 4i if I were to just shorten that?
4i.
It's just 4i. So really all we're doing is making sure that whatever the imaginary term is, it takes the opposite sign. Your imaginary term. So you could have actually gone straight from the end, from the beginning to the end here. As long as you understand, it's always the imaginary term that's going to change signs there. If it was positive, it's going to become negative. If it's negative, it's going to become positive. Let's do this one. Is the real number written first? Okay, so what is my conjugate going to be? 9 plus I. Done. That's all there is to it. This is the easy part. You've already done the hardest part. Moving on to D. Is the real number written first? No, so how should I rewrite it?
3 plus
And then what would the conjugate be?
3 minus 1. I have a question. I didn't see A. What was...
Yep. All right, let's do E, the last one we're going to do for this. Now, again, you can do this two ways. If you want, you can write it out the long way, or if you already feel like you're comfortable, like, oh, I know what that is, I feel like this one shouldn't be too terrible. It would just be 8i. So I'm going to show you the long way, but you could jump straight to 8i on this. It's 0 minus 8i. The real part came first, the imaginary part came second, so then the conjugate would be 0 plus 8i, and 0 plus 8i is just 8i.
So it says you would run off any point, they're just going to 8i?
No, because, now I can tell you this, it's only the, but be careful, because sometimes, like, if it's written wrong, like, people change the wrong one. The biggest thing here is, the reason that I do it like this is that we understand that the real number has to come first, just to get the pattern down. So if you feel like you've got this pattern, I don't doubt that many of you do. Like that you could go, okay, I've got this, no worries. Now one last thing. The last section we're going to go over today. Okay. Notice this is I to the 13th power, I to the 2nd power, I to the 47th power, and I to the 24th power, which is actually super easy to figure out as long as we're only talking about I. Okay, so here's what we need to understand. You might want to make yourself a note here. We learned yesterday that I is equal to what? What is it the same thing as? Oh, well, it is, but
Square root of -1.
the square root of -1. So if I wanted to know what I squared is, I would have to square both sides, right? So I squared is the square root of -1 squared. I squared both sides. So what is the square root of -1 squared? Right, this is going to cancel out with that, leaving just negative 1. You're going to want to make yourself this little chart that I'm making because I'm giving you a cheat sheet right here. Like what I'm doing on the side is going to be a nice little cheat sheet. Every single time in the world, I will be equal to the square root of negative 1. Every single time in the world, I squared will be equal to negative 1. Well, then what would I to the third power be? Would you agree with me that I to the third power is the exact same thing as I squared times I? Are we okay with that? Okay, and I already know that I squared is what? It's negative 1 times whatever I is. What is I? Okay, so negative 1 times the square root of negative 1. Well, this is just going to end up, I don't know what the square root of negative 1 is, so it's just going to end up as negative 1 times I or negative I. This becomes negative I because the square root of negative 1, I can't calculate that. I can only tell you that it's I. And I take I and I multiply it by negative 1, I get negative I. So just let me do some color coding here so we can show exactly what's happening. I becomes this. I squared becomes this. I to the third power becomes this. And we only have to learn one more. You're going to have to learn these 4. And if you can learn these 4, your life's going to be easy. I to the fourth power. Would you agree with me that I to the fourth power is the same thing as I squared times I squared? So I squared is what? So it's negative 1 times negative 1. And what is negative 1 times negative 1? Positive 1. So what we get here is this. These 4 patterns. If you can remember this, then you can do I to the 1,000,000th power. You can do it to whatever power. Like we are going to be able to do any sort of I. Now here's how we do it. We're going to use this and come back to this in just a minute as a cheat sheet. Notice that there are 4 choices. I'm going to tell you that every I in the world will be one of these 4 choices. It's going to end up as one of these 4. Yes, sir?
Is the I to the fourth, where it says 1, is it still an imaginary number?
No, because I squared becomes negative 1, right?
Yeah.
And negative 1 times negative 1. So when I take I squared, it is no longer imaginary. It becomes a real number.
So I squared and I to the fourth, they're both.
Right. I squared and I to the fourth power, those even roots are going to end up as real numbers. The odd roots are going to end up as imaginary numbers. So let's try this. Here's what we're going to do, and this is going to be our step every time. We are going to divide the exponent by 4. So here's what we're going to do. Let's take this exponent and divide it by 4. So I to the 13th power, we're going to take 13 divided by 4. So 13 divided by 4, let's do that. 13 divided by 4. 4 goes in there 3 times, leaving me 1 left over, which is, does not go into 1, bring down, we get 3.25, right? 3 1/4.
Question.
Yep.
When you divide exponents, don't you subtract them?
This is just, we're not actually doing I to the 13th divided by I to the 4th. We're just going to take 13 divided by 4. This is like a trick to figure out all the others. So we've got 3 1/4. Okay, so what we've got, okay, I'm looking for the best way to show this here. Let me just show this real quick. We've got 13 I's. Let me show you what we're actually doing with this so that when I actually do the division, it kind of shows you what's happening. So I'm going to divide that 13 into groups of 4 since we're dividing it by 4. So we've got I to the 4th, I to the 4th, that's 8 of the I's, times I to the 4th, that's 12 of the I's,
And then just I.
and then 1 single I. So every single time that we've got, okay, so what we've got here is we've got these groups right there. There's 4 groups. And really what I want to look at is this one right there, the last one left over. Or there was this 1/4, meaning it is the first one of these 4. Like, right? It's going to go 3 and 1/4. But really what I'm going to look at here is this 1/4. Notice that there are 4 choices here. I want to look at the first choice of the 4 because it's first out of the 4, one of the 4. Which tells me there that my answer is going to be the square root of -1, which is better written as what? How do we write the square root of -1? I. So we're always going to be writing one of these, that it's like the square, that we get I is equal to the square root of -1, which ultimately ends up as I. So we're going to go, okay, that's just I, because we had 1 left over. Bear with me here. The second one is I squared. Do I need to divide I squared by 4 to know what it is? No, that's already on our chart. What is I squared? Okay, so that's just going to be -1 because I notice over here that my I squared is -1. But I to the 47th power, that is much more than on this chart. So what I'm going to do is I'm going to take 47 and I'm going to divide it by 4. It goes in 11 times, leaving me 3 left over. Or it goes in 11 and 3/4 times. So again, this is the part that I care about here. I'm going to look at the third out of my 4 answers there. The third one out of my 4 answers, meaning the third power right there, is right here. What is I to the third power? -I. So my answer that this, when I actually work this out, will be I. Okay, so we've got I to the 24th power. So we're going to do 24 divided by 4, which gives me 6. So this is the same thing. What that tells me is that this is the same thing as I to the 6th power. So, which is the same thing there, is there's nothing left over, right? We've got, like, if you wanted to look at it, all of these, there's no left over. There's not 1 out of 4. There's not 2 out of 4. There's not 3 out of 4. Really what we've got there is that all of those are filled up, the 4 out of 4. We never say 4 out of 4, right? Like, we don't write fractions as 4 out of 4. Why not? Because it becomes a whole number like we have right here. We have a whole number, which means when you have a whole number, it's going to be this 4th choice. Like, right? This would be 1 out of 4. This would be 2 out of 4. This would be 3 out of 4. And whenever I get a whole number, that's the same thing as 4 out of 4. And what is the answer if I have a whole number 4 out of 4 there? This just ends up as 1. So when you do the division, here's what's going to happen. Here's the short version. You're going to do that division. You're always going to take the exponent. You're going to divide by 4. And you're going to end up in one of these scenarios. You're going to end up that your remainder is 1/4. You're going to end up with a remainder of 2/4. You're going to end up with a remainder of 3/4. Or you're going to end up with a whole number. And if you end up with a whole number, your answer is just 1.